Assalamu alaikum guys. Okay, so in this lecture we are gonna do the first 5 MCQs of October-November 2009, paper 1, variant 1, chemistry, AS level. Okay, 9701. Right, so let's get started. By the way, the next 5 MCQs, the link for the next 5 MCQs has been given in the description. So after this lecture, you may check that out as well for the next 5 MCQs. All right, so let's start out from the first question. It says that an element X consists of 4 isotopes. The mass spectrum of X is shown in this diagram over here. Okay, this is the relative abundance axis, and the mass M over E ratio is given on the x-axis. What is the relative atomic mass of X? Okay, how to calculate the relative atomic mass of X? Well, this is pretty easy. If we multiply the relative abundances by the M over E ratio and then add them up, we'll get the relative atomic mass for each isotope. Each line over here represents an isotope. So now I've just multiplied. Okay, the abundance corresponding to the first isotope is 50%. So 50% means 50 upon 100 gets multiplied with 90. Then we'll add it to the next one. The next one is corresponding to 10%. Do the same for that one. And then for the next one, which is corresponding to 20. And then the last one is also corresponding to 20. So do the same thing and you'll get 91.3. The correct answer is B. Now let's move on to the next part. Okay, this is moles, a very good question. Zero point 0.2 moles of a hydrocarbon undergoes complete combustion to give 35.2 grams of carbon dioxide and 14.4 grams of water as the only products. Okay, guys, so as you know from your theory part that complete combustion yields only two products, carbon dioxide and water. This is the general equation that you can use for any hydrocarbons complete combustion in which you get carbon dioxide and water. I would really suggest that you guys should learn this equation because it is very helpful in such calculations. Now, it's given that zero point 0.2 moles of a hydrocarbon are used and 35.2 grams of carbon dioxide are produced and 14.4 grams of water are produced. Since the masses are given, we can use them to calculate the moles of water and the moles of carbon dioxide by using the formula of moles equals to give mass given mass in grams upon the molar mass of that element or compound. So just do that. Calculate the moles of carbon dioxide which have been produced. So the moles of carbon dioxide equals 35.2 divided by 44, which gives us an answer of zero point 0.8 right over here. And do the same stuff for water as well. Divide 14.4 by the MR of water, which is 18. It gives us 0 0.8 as well. Now, over here in this equation, these X and Y upon 2 actually represent the simplest mole ratio with 1 mole of the hydrocarbon, which is unknown over here. Okay, so this actually means that 1 mole of this hydrocarbon produces X moles of carbon dioxide, and 1 mole of the same hydrocarbon will produce Y upon 2 moles of water. Now, for this, what you need to do is just calculate the simplest mole ratio of the actual moles they have given in the question. Now the actual moles are 0.2, 0.8 and zero point 0.8. Divide them by the simplest moles, the smallest moles which are given. So it becomes 1 is to 4 is to 4. Now these 4 and 4 correspond to X and correspond to Y upon 2. So the value of X becomes 4 and the value of Y upon 2 also becomes 4. So the value of Y equals 8 and the value of X is 4. So therefore our answer is C4H8. So that D is our answer over here. Now let's go on to the next question. Number 3. Okay, the graph represents the variation of a property of group 2 elements. Okay, this is a group 2 chart. Beryllium, magnesium, calcium, strontium, barium. Okay, now this is a property that is actually decreasing down the group. So which property decreases? Let's look at the answer options. If we look at the ionic radius as we go down the group, the number of shells are increasing and therefore the ionic radius increases. It does not decrease, so A cannot be the answer. What about ionization energy? Yes, ionization energy decreases down the group because the atomic radius is increasing and hence the charge density is decreasing. So if the charge density decreases, therefore ionization energy decreases. So Bravo is the correct answer. Now let's move on to question number 4. The antidote molecule shown can help to prevent liver damage if someone takes too many paracetamol tablets. Okay, this is paracetamol molecule. Now what is the order of increasing size of the bond angles X, Y, and Z? All right, these bond angles are asked X, Y, and Z. If we look at X, we have two lone pairs and two bonded pairs. So this is actually resembles a structure of a bent molecule. The structure of it resembles the structure of water. Water also has two lone pairs and two bond pairs, and from theory we know that it is equals to 104.5 or just 105. So 105. So X is approximately 105 degrees. If we look at Y contains four bonded pairs. This means this is a tetrahedral structure and has a bond angle of 109.5. And if we look at N has a lone pair and three bonded pairs. So three bonded pairs, one lone pair represent a pyramidal structure having a bond angle of 107. So now let's arrange them. So in order in decreasing size of the bond angles, decreasing size means the biggest will come first. Okay, so which one is the biggest one? 109.5 is the biggest, so Y comes first, followed by our Z, and then followed by X. So C is the correct option. Then let's go move on to the next MCQ that we have to do in this lecture. Okay, which molecule has the largest overall dipole? Okay, dipole can be calculated by calculating the difference in electronegativities. Difference in electronegativity. Okay, electronegativity, as you guys know, that it is the tendency to attract lone pairs of electrons. And if we look at the periodic table, the electronegativity varies in this pattern. It going up the group, across the period, and diagonally it increases. All right, so this is how the electronegativity increases. If we look at option A contains four chlorine atoms. This is a symmetrical molecule, and symmetrical molecules would mean that the dipoles get cancelled out in each direction. There are the electrons are being pulled equally, so their force of attraction gets cancelled out, and so A has a zero dipole. What about D? D also is symmetrical. It contains two electronegative oxygen atoms, pulling the electron density towards each other with an equal force, so they cancel out as well. So D cannot be the answer option. Now, what about B and C? Okay, in both of them, we have oxygen and we have two hydrogens. We have oxygen and we have two chlorines. Okay, in both of them, the electronegativities of the bonded atoms differ. But if we look at the electronegativity difference between oxygen and hydrogen, there is a larger oxygen difference in electronegativity between oxygen and hydrogen as compared to oxygen and chlorine. So again, C cannot be the answer. So the best option is B, because B has a larger overall dipole as compared to C. Okay, so guys, that's it for this lecture. The link to the next lecture has been given in the description. Please check that out for the MCQs number 6 to 10.